And since it was launched, it's already made 2 orbits around the sun. It will make 24 orbits. And over those 24 orbits, 7 times it will pass Venus. And the reason is because part of the thing we have to do is we have to slow the spacecraft down. Because when I leave the Earth, even when I'm going towards the sun, the Earth is moving at many tens of thousands of miles per hour as it orbits the sun. So the spacecraft doesn't go like this, it goes like this. So I need something to help me slow down, or help the spacecraft slow down. So we use Venus to do that. So 7 times it flies by Venus, and that slows it down ever so much. And so each orbit after it passes Venus, it gets a little bit closer and a little bit closer. And so it will continue to get closer and closer, but it has already gotten closer to the sun than Helios. It's already the closest spacecraft, less than 25 million miles from the sun, so more than a quarter of our way in. It's also traveling faster than any spacecraft has ever traveled before. It's traveling at its fastest so far as more than 150,000 miles per hour. So here's what it looks like. It launched from the Earth, and it will continue to make orbits. Every so often it will pass by Venus. Remember, 7 times to slow it down. In 2024, it makes its closest approach. It will be within less than 4 million miles. It's 3.8 something million miles. When it makes its closest approach, it will be traveling more than 450,000 miles per hour. Almost 500,000 miles per hour. That's incredibly fast. Faster than anything we've ever done. So there has been data that's been downloaded. All of that data is being currently looked at by scientists. So it has not been released yet, except they've released a few images because the spacecraft actually has cameras on either side. These cameras are wide field cameras, incredibly high resolution, because they're looking at the stuff streaming off the sun and imaging it in real time. And so this is the first image from the camera, and you can actually see the Milky Way, and you can see how many stars are in the image. So incredibly detailed, incredibly sensitive camera. Here's another image, and that's actually the Earth seen from Venus. So we're looking back from Venus, and you can see the Earth in the camera. So that's one of the instruments. Other instruments will measure particles coming off the sun. It will also measure electric and magnetic fields. And so we're going to go to where all these huge solar eruptions, solar explosions are occurring. The region that you see during those beautiful solar eclipse images. When you look up at a solar eclipse, when you're looking at totality, you'll be seeing the region that Parker Solar Probe is flying through with your own eyes. So I really encourage everyone to think about going to it. So it's made its closest, when it makes its closest approach, just to give you another idea of how fast that is, to go from Philadelphia to Washington, D.C. would take 1 second. That's how fast. So less than 4 million miles, 3.8, and it takes 88 days for it to make one of its orbits. So it's going to be making 22 more orbits. It's in its 3rd orbit right now. So we're on our way. We as a society are finally sending a spacecraft to the sun. We're going to go up close and personal to understand our own star. And learning about this not only tells us about the environment that the sun creates, but it tells us about all the stars in the universe. We're learning about what it takes for a star to make a solar system habitable. What we learn about our own sun tells us about the many thousands of solar systems that we've already discovered outside of our own, telling us about the very evolution of life that a star creates. So this is not just telling us about our own backyard, but it's giving us a glimpse at what's happening in the rest of the universe. So lastly, I will encourage everyone, If you get a chance, think about 2024. There is another total solar eclipse next year in South America, but I think 2024, the one in the US, is probably a little more accessible to everyone. In the middle of the path, you will have up to 4.5 minutes of totality. It's a long time. It's a big path, starting in Mexico, going all the way into Canada, not too far from here, upstate New York. It's just an afternoon's drive. Make your plans now, because I will guarantee you that when you see a total solar eclipse with your own eyes, it will change you. It is so much more than an exciting scientific experience. It is a life-changing, and it is an experience that you will never forget. So thank you very much. So, do we have any questions? Yes, sir. I'm going to come down to you.
So what's the fate of the Parker Solar Probe after its mission?
Okay, so what's the fate of Parker Solar Probe after the mission? So, 2024, it reaches its closest approach. It has 2 more years of nominal lifetime. So 2 more years that are planned for. But there's enough fuel that as long as everything works okay, because things can always go wrong. But I will say, I have to hand it to NASA. They've done a pretty good job. Most of their spacecraft have lasted way longer than their lifetime. Hubble, for example, or even the Voyager spacecraft. So it will continue to operate. It will be at the same distance, and will continue to orbit, and will continue to bring back science for hopefully 5, 6, 7 more years. Now, once it reaches the end of its life, once it runs out of fuel, it will start to drift. So remember, once it drifts and pieces of the spacecraft are now not in the shadow of that heat shield, as long as that tail pokes itself out, it's going to basically burn up. And so the spacecraft will start to break up, and it will become a cloud of Parker Solar Probe as it breaks up into smaller and smaller pieces, and it will continue to orbit the sun, and eventually it will be absorbed by the sun's atmosphere. But that'll be many, many years. Yes, right there? Yes, ma'am.
Hi, what information are we actually trying to acquire through this Parker Solar System?
So what information are we trying to acquire? Well, what we're trying to understand is some key features, and I didn't go into the details, but we're trying to understand why is the sun's atmosphere so hot? I mean, one of the things that's unique about the sun is you move away from the surface of the sun and go higher and higher up, it actually gets hotter. The surface of the sun is about 10,000 degrees. As you move up into the higher layers, and those are actually the images I showed you from SDO, they're showing you hotter and hotter parts of the sun. It actually goes up to many millions of degrees. So that's one of the questions we want to understand. Because what that energy is that's driving that is also driving solar activity. It's driving these huge explosions, solar flares and coronal mass ejections, the things that impact us here on Earth, or the things we put in the solar system. So we need to understand the fundamental physics of why that is, why those things are happening. And the only way we're going to do that is by taking direct measurements. So that's why we're going there. We're going to where this physics is actually occurring so we can truly understand it, and ultimately so that we can potentially predict it and predict the weather on the sun, much like how we do here on Earth. You're welcome.
Hi, you mentioned earlier about the solar panels causing an issue because they can't function as well when they're very hot, and I was wondering if you knew how they actually got around that issue.
Well, so what they do is they've actually created a radiator system, okay? So there is a special type of radiator that was built in the solar panels that using a gallon of regular water that flows through those radiators and actually radiates the heat. It gets rid of the heat. It takes it to the backside of the spacecraft, because remember, the backside is actually behind that heat shield facing away from the sun, and it's actually very cold. Because in space, when you're not facing the sun, when you're not directly at the sun, the other side of anything gets really, really cold, okay? And so they're taking that heat, using the radiator to put it to the back of the spacecraft, and that's how they keep it cool. Yeah.
Alex, thank you very much. That's all the time we've got for tonight. Please
All right.
join me in thanking C. Alex Young.
Okay. Thank you. You guys are welcome to send me questions. There's my email, also Twitter, if you want to send me a tweet. I'm happy to take it at The Sun Today. Also, I have a website called thesuntoday.org. Thank you.
Thank you, Alex. And that concludes our program on the main stage for today. However, we still have another show at 5 p.m. going on exactly above us on the planetarium, titled Moon to Mars. So we'll learn all about the Apollo 11 mission, the trajectory and the landing, and then we'll learn about the missions going to Mars, some of the landing sites, some of the beds waited for, all of it in live data from open space with Carter Emmert and a couple of other people. So that is open to everyone and it's free with museum admission. So if you'd like to go, it's first come, first serve, unfortunately. The line will form right outside those elevators if you want to just